Okay, can you see my screen?
No.
No. I'm doing a screen. Oh, let me do this share. Hold on. Yeah, I have to say share screen, right? Okay. Okay, can you see this now?
Yes. Yeah.
Okay, let me go into play mode. Okay, great. Thanks for having me. I'm going to give a talk today. A talk I've given a few times at some other business schools on data science leadership. Just a little bit about me. I run a boutique consultancy in San Francisco, California, where I've been doing consulting work with machine learning and data science and AI for over 15 years here in Silicon Valley. I did my PhD at the University of Chicago in theoretical chemical physics and did my postdoctoral work actually in the physics of AI. So I'm kind of amazed that this AI stuff has all become so popular. I've been doing it since the 90s. But it's all, you know, so we're going to talk today about sort of how you can apply this stuff in industry. I've worked with a lot of companies like Aardvark, which was acquired by Google, with eHow, which was the first billion-dollar IPO since Google. A lot of Wall Street firms like Gerson Lerman Group, Barclays Global Investors, BlackRock, and Roche, Fortune 500 firms, tech firms, and in the investment space. So I've seen a lot of data science and how it's evolved over the past 15 years or so. And I just want to kind of give you guys a overview of what to expect when you come into industry and you start managing these projects and what they're going to look like. So I just want to kind of start off with a couple of failures, actually, big news items. I don't know if you saw this. There was a recent, I do some consulting work in the medical space, in particular in the pandemic. And one of the things that recently happened is Epic Systems produced this artificial intelligence program and released it to hospitals to try to predict sepsis. And apparently this has just been a complete and total disaster, totally failed. And it's just astounding because Epic is the nation's largest electronic health record system. They have massive amounts of medical data. And there's this huge question of how could they have produced this machine learning algorithm and deployed it to hospitals, and it just completely failed. And the analysis of this is that they were basically, here the statement, the definition of sepsis based on billing codes is imprecise and not the one that is clinically meaningful to health system or patients. So just a perfect example of someone trying to use data from a billing system to try to create some sort of clinical diagnostic. And that's kind of got a bit of a theme of kind of the things you're going to see today when I talk about what happens when trying to run data science projects. Another very popular example, if you haven't seen it, it's been all over, and certainly in the AI and ML space, has been Zillow. Zillow is a firm that's an online search engine for real estate. You can buy and sell houses there. And apparently they made this machine learning AI algorithm. They were using it to price houses on the internet. They went out and bought a huge number of houses, and it turned out they bought them way over the market price, and now they have to dump them, and they have to lay off 25% of their staff. Which is astounding. I've actually seen this before at eHow, a very similar situation. And so how did this happen? How does it that they built this data science machine learning algorithm and ended up, basically blowing $300 million? And again, an example of, and nobody really knows. There's a lot of speculation. Was it the incorrect use of machine learning? Was it too much trust? Was it aggressive management? The wrong KPIs? But I think the CEO has admitted that, look, we put a lot of faith in this algorithm that we built using our data to try to predict the prices of houses. And we just put way, way too much faith in this. And it just blew up on them. So how is it that these things happen? Because obviously these are the kind of things you want to avoid. If you're going to run a successful data science project inside a company, you would like to avoid these kinds of problems. So I'm going to kind of talk about what you're thinking, sort of my approach of how I think about running these projects and what to avoid. I sort of always start with this idea, look, from The Onion, science is hard. Data science is hard. It's not engineering. It's not IT. It's something else. And you have to take a very different management approach to these problems if you expect to be successful. So sort of become the idea of, the goal, I think, of a lot of companies we're seeing now is they want to become data led. They want the data to lead them. What does that mean? Well, you might say if you're in a company that you're informed by data, you're data informed, and that means that you have operational visibility into what's going on in the company. To say you're data driven might mean, well, there are various tools that you have, analytics tools that you can use for insights into the organization, try to help you grow and grow the organization. And then a lot of companies try to be data informed. You might be surprised at how bad the information is. Sometimes it's even conflicting. Data driven is certainly happening now. People are trying to drive growth through data. Being data led, meaning that you can automate systems and create innovation, is very, very hard. And we've worked with a lot of companies trying to do this. It's very, very hard. It's a very hard thing to do. It's very new. But this is where a lot of organizations want to go. They want to become data led. They want to use their data to try to do to automate systems. One executive said to me, "How many people can I fire, if I do this?" But others who are trying to innovate and create new products or processes. And so I want to talk about sort of what I would call basically 4 steps. How do you do this? You need to have a strategy. How do you leverage your data? You need to understand what stage you're in. What if you're in a company, and how mature is the data? You're going to need to have a team to work on it. You can't do it by yourself. So, what does the team look like? What kind of team do you need? And then what kind of tools do you need to get to this point? So I'm going to kind of discuss these 4 basic issues: stage, strategy, stage, team, and tools in this order, and sort of talk about some of the uncommon things that might come up that you might not expect. So in terms of strategy, I like to use strategy when I think about data science. I think about data science as a sort of like a gas station. You want to open up a gas station, and I'm trying to invent an algorithm that will help me improve the business. Well, algorithms predict supply and demand. So if you want to open a gas station, you might say, well, I want to go where there's a lot of traffic. So, here is the left side, see a lot of traffic. But the problem in places where there's a lot of traffic is that there are a lot of competitors. And so if you have a lot of traffic and a lot of competitors, you're not going to do very well. So you might go where there's less competitors. Right? Let's try to optimize our marketing spend, or let's try to get our search engine working, or let's try to do our ad spend where there are less competitors, but then there's no traffic. And so what you're trying to always do is find this sweet spot in between where there's more traffic than there are competitors. There's some space where you can predict something, the traffic is there, but you have an opportunity to sell something or to innovate in this space. And this is a good example of, I think, a lot of how these algorithms work. Certainly the Zillow algorithm is something like this, right? Where they were expecting, hey, we're going to find this sweet spot where there are all these houses we can buy, but that basically there's a lot of people wanting to buy houses. We'll go in and buy them. And obviously something went wrong because they mispriced them. So, but in terms more in strategy, in terms of data science, we typically think of data science as framing, solving, and acting. So, a lot of people want to have a process. When I go into clients, say, what is the process you use? People ask me what the process is you think, but you need to frequently give people a process. So the process would be, well, first you're going to acquire domain knowledge about the organization you're in. So try to acquire knowledge about what they're doing, and then formulate some hypotheses about what you think would be a good strategy. What kind of algorithms or data, how can we use it in the organization to, to achieve some business objectives? Then we want to get model. We need to figure out a way to get model for the data, generate model. You want to generate some models around the data. So you're going to go and collect some data that you have, and you're going to create some models around this. Maybe it's a regression model. Maybe it's an AI model. Could be in Excel, could be using some fancy deep learning tool. Then you want to predict something. Like typically you try to predict revenue. Can I predict revenue from a model? Can I predict the price? Can I predict the price? Can I predict the revenue? Can I predict the traffic? Then you need to find a way to test your predictions. And typically, if you're in finance or in the stock market, we work in Wall Street, you try to back test it. Is there a way you can show that your models actually would, if you had run them in the past on data that you had in the past, would they have worked? So, for example, I'm working with a company as a search engine. We want to figure out how do we improve the performance of the search engine. I design a model to try to, when you search for something on an e-commerce site, maybe you're searching for yogurt, it's going to show you various forms of yogurt. Which yogurt would you click on? That's an enormous, enormous market. It's an enormous thing, especially with all the online shopping going on now. So you want to go back and ask, gee, if I had shown these products to people last month, would they have purchased them? Where would they appear in the click stream? So you have to backtest your models. So that's framing and solving. Then you want to act. You want to try to get your model into production, and you want to attribute gains to the models. And I would say today in industry, the acting part is very, very hard. Getting things into production, testing them properly, and doing attribution. This is a very, very complicated problem. A lot of companies don't do it well. This really sometimes requires some very sophisticated statistics and statistical analysis, causal analysis. It's complicated. When I was at BlackRock, which is the largest hedge fund in the world, largest financial institution in the world, we had 8 different systems of attribution, and every one of them gave different results for our models. So, but this is sort of the framework we try to use: framing, solving, and acting. So from a strategy perspective, this is sort of like the highlights. And the thing about data science is that it's very different from other types of processes in the organization, because the data touches usually every part of the organization. And because of that, you have to use more systems thinking. You have to leverage the interrelationship, say, between data and marketing and the customer. You're going to be working very closely with the business units to understand what they're doing, but also how the customers are performing. And what happens in data is that because there are so many people touching the data, it ends up you really have to think very broadly about it. Moreover, there's a lot of knowledge transfer that goes on because, people just don't know what's in the data. So, you're going to be, when you work on these projects, you really have to develop a sense of personal mastery and team learning so that people understand, what's in the data. Not only do you need to have domain knowledge, but you have to understand how the data actually functions. You then want to try to create some mental models of what you're doing. And this is kind of tricky, right? Because you might have someone who's a quant or a physicist or a machine learning person building these models, and they're very technical, but you have to somehow translate this into a mental model that people in the business unit like yourself can understand, because it's very easy to come up with models that are just sort of pie in the sky models, and they don't really do anything. And they don't really solve the business problem. And we see a lot of that in industry, that people come up with models, they think they solve the business problem, they put them in production, they don't work at all. So there's a lot of disconnect there. And then knowledge sharing, you have to share knowledge, and so share knowledge within the organization about what you're doing. And again, the reason I bring this up is because from a strategic perspective, because data touches so many points in the organization, and frequently organizations are very siloed, especially organizations that are organized around IT. IT has become very siloed. You're going to have to work within different groups to get your data projects running. So you have to be able to bridge these gaps. So, one of the things we try to really get across to people doing data is that data science is not information technology. It's not IT. It's very different. IT is sort of, you have a product, you have a database. I'm going to install the database. I test the database. I put data, you have vendors come in and do this. That's fine. They do that. They're very good at it. Data is quite different. It's very cross-functional. Somebody, in the finance team or the marketing team might be inputting data into the database, and the engineering team has to use it. It's very autonomous. Because it's very autonomous, it's different from the traditional engineering product lifecycle, especially because data is coming in from all sorts of sources and people are modifying it all the time. It's very experimental. It's experimental because you're forming a hypothesis, you're analyzing data, you're making predictions, you're running back tests, you're doing A/B testing. So this is very different than a lot of organizations where you're just building something or you're deploying something or you're executing on a process. The process is very experimental, and a lot of organizations are just not structured or culturally structured to do this sort of experiments. It's going to take some time to really understand how to do this. Sometimes I could say with current clients, take up to a year up to a year of working with them full time just to get one experiment running in production. And I even say now we haven't figured out the back test and the A/B testing. We're still trying to get them just to understand that. So a full year just to get to that stage. And then the other thing about data is that you want it to be self-sustaining. You don't want it to be a cost center. A lot of organizations will set up, I have a data lake, I've installed Hadoop, I've got a database system, and it's basically a cost center. Data should not be a cost center. Data should be used to generate revenue. So these are the things that we try to think about and get organizations to really embrace, or at least kind of nudge them in that direction. Now, a lot of the problems that come up are examples of things when you're dealing with strategy is you're going to deal with externalities. And this notion of externalities, an example would be like with the Zillow case where Zillow purchased a lot. They built a model, they priced the model, they used it to buy houses, and then probably the market moved. How did this happen? How is it that you have all this data, you built this model, something outside of the data science team, something happened to their models? And, I think what people kind of assume that happened is that, well, a lot of people in the neighborhood figured out that Zillow was buying houses. And so they started dumping that, they started selling all the lemons to them. Then the prices went up. And this is a very common problem in dealing with modeling and data modeling, is that you have these externalities in the business. And when you're dealing with your data science teams or your data modeling teams, they're not going to think about this. They don't understand the externalities because they're not really involved in the business. They're really doing technical work. And so you really have to understand that these sort of, if there are external factors which are changing, you have to anticipate this. So that's sort of like a brief, a bird's eye view of the strategy. In terms of stage, we want to, you've developed a strategy, you want to come in, you want to do something. The first thing you have to do in any organization is figure out what stage is your data in. And I can tell you that of all the projects I do, projects fail when the data is wrong. There are problems in the data and you don't know about it. And this happens all the time. And so you have to anticipate where the problems are in the data early. And so first example is, where is your data? Is it in a transaction database? Is it in web logs? Is it in a third-party system? Is it in a data lake? What product does the data service? What was the data originally intended to do? And this is a critical idea because data is only as accurate as its original intent demanded. If you put data into a billing system, the data is accurate to bill your customers. If you try to use that data for something else, it may not work because you're not using it for billing. So is the data you're going to, and this is what's happening in a lot of organizations, that they're taking data from one product line and trying to use it in another product line. And what you're finding is that there are all sorts of problems. But you first need to understand what was the original intent of the data. Then you need to understand, can you access the data? Or is there security? Are there regulations? Are there compliance requirements? And finally, you need to know who owns the data, and in particular, who's responsible for the quality of the data. Now, one of the common problems that comes up, and I want to focus on this because it's something which is, I think, the key problem that arises in data projects, is what I call data quality mismatch. Again, this idea that data is only as accurate as its original intent demanded. Whatever the product was built that loaded and logged that data, that's what it's for. So here's a very good example. You have a billing system. Most companies, the billing data is very, very accurate. Why? Because what is a company? A company is an organization that bills their customers. And if the billing is wrong, you might have 1 million customers and they're going to be calling you up and banging on your door saying, hey, there's something wrong with my billing data. So chances are your billing data is very, very accurate and you can use it. And you might come in as a strategy and think, okay, I have billing data. I want to build a recommender on my product. I want to put a recommender on my website to recommend what products people like. If someone buys t-shirts, maybe they need shoes. And that's a common type of recommender. And you might think that makes sense. I have the billing data. I know what people have purchased. I'll build a recommender from the billing data. I'll put it in production. I'll get a revenue lift. And a good recommender can give you a 50% revenue lift. I mean, these are certainly in the online services, these are big products. Here's the problem. the metadata, your recommender may require metadata. Okay, the metadata may be totally wrong. There could be missing, there could be problems in it. And the reason for this is because the quality of the product metadata may have no material impact whatsoever on the billing system. So for example, if there's products you're worried about, what category is the product in, or how long has the product been in our inventory, that information could be totally wrong, or it might just be missing, and it just doesn't matter, because when you were billing your customer, they didn't care how long the product was in your inventory. But if you're trying to build a recommender, that really matters, because you don't want to recommend products to people that have been in your inventory for 3 years and have never sold, or maybe you do, maybe you're trying to get rid of them. So this is the common problem, data quality mismatch. And the thing is, this occurs everywhere. It's not just in billing systems. This is exactly what happened in the Epic system we described earlier. Epic and EHR system, they tried to build a system for medical diagnostics, but they used billing data. So what happened? Look, if I'm doing medical diagnostics, what is an EHR system? Electronic health record. It's basically used to bill the insurance company. So there's probably someone in the hospital whose job it is to enter in the medical record information. Well, maybe they do it on Friday, and maybe they enter all the information on Friday, and they say, okay, this person got sepsis and now it's Friday, but really they got sepsis on Monday. But the data says that they didn't see it in the record until Friday. Well, why does that matter? Well, for billing, who cares if they're 3 days late on they got it wrong? But if you're trying to do clinical diagnosis, it's critical that you understand what day the person got the sickness, because you can't predict, you can't predict anything. So this data quality mismatch is one of the biggest problems you're going to find in trying to build data products. So what's the solution? The solution is you have to be paranoid. You have to test everything. As Andy Grove said, only the paranoid survive. So, in software engineering, we call it paranoid programming. And there actually is a whole software IT thing called paranoid programming, where basically when you write your software, you're trying to anticipate every worst case scenario and you test things. But the thing about software is that if it's bad code can be fixed. Bad data usually has to be thrown away. If you have a logging system and you're trying to log what your customers clicked on and you log it incorrectly, not only do you have to throw that data away, you can't go back in time and relog it. So you have to go in early on every project and ask, what's the data quality and how do I test it? Here's another common problem that comes up all the time, sort of in a different industry, which is in banking. And you may not realize this, but this is a great meme that somebody sent me yesterday for this talk. The entire banking world and our whole economy is built on Microsoft Excel, and which is terrifying if you realize what's going on. So this is another problem that comes up. We talked about this issue of data access. I call this problem, and this is actually coined by a friend of mine in the banking industry, the problem of data contraband. So here's what happens. You go into you want to do a data project. Okay, you need the data. The data is stored in some database. You need to make a report. So you go and you pull the database, your data out of the database into a spreadsheet. And then now you've got a data in Excel, and then you make a report. Then somebody asks you for that data. So you email it to them. Okay, now instead of that person going to the database and using a piece of software and pulling it out, they got it from email. Next thing you know, there's emails with data floating all around. And you might have I actually heard this from a fellow at one of the major investment firms, I can't say, who said, yeah, we had this problem that, there was a guy who worked for us. All his data was in his emails. He was emailing it back and forth to people. He left the company, and now we have to go into his email logs to get the data that we need. And it's a disaster. So, and moreover, it's, so basically think of it like, you're asking to get data from a friend, but this causes a massive compliance problem. So you might be going to an organization saying, I have to deal with data compliance. And you find out people are just passing spreadsheets around left and right and emailing each other data. And this is just a nightmare. And I know so many people who work in the industry. I have one fellow who was a friend of mine who is a head of data at a company, says, my entire career lives on data contraband. It's all he does. But this is a huge problem for data. So what are the solutions to this? Well, one solution is use stored procedures, or Spark. In other words, you move the functions to the data. You don't pull the data out of the database and do things. You try to do things inside the database so you remain compliant. Maybe you can't do that. So maybe you do have all these spreadsheets. Well, I talked to a very large firm in Europe that, well, I think if I remember, it was the may have been the investment house for the Catholic Church, and they have all this data in spreadsheets for all of their real estate properties for the entire Catholic Church, and they're trying to get it all into SAP. And this is like a multi-year project to get every piece of data that's in a spreadsheet, stick it into SAP, so at least you can start tracking it. And so you actually, I mean, you actually don't. There are places that are so large they don't actually know their assets, because you have 300 people in the organization. Everyone has their own data sets. Everyone has their own spreadsheets. Nobody knows what the total assets of the firm are. When I was at BlackRock acquired Lehman Brothers. Lehman Brothers had 2,000 databases set up. They had more databases than they had customers. We had to unravel that entire mess. So, if you start seeing, if you're passing data around, one of the solutions is try to get into some sort of tracking system where you're getting people to use an environment where they're still functional, like an SAP or a Google Sheets where you can track it. The other option is if you're using systems like email, Gmail, Outlook, there are document tracking systems, Jira, GitHub, Confluence. There are some fairly good document tracking systems that are used that you can use to solve these problems. Now, I want to move from stage. We talked about strategy. We talked about the stage of the data. I want to talk a little bit about the team. Typically, when you think about a data team, there's a nice little diagram, a Venn diagram I got where people talk about, well, you need people who can hack, people who know math and statistics, and people who have experience. That's all true. Sort of recruiting. But I like to give this slide to explain sort of how I think about data scientists in the tech world. For those of you who've seen The Big Bang Theory, which is a very popular TV show for a while, I like to see, look, all data scientists are not the same as software engineers, and they're not the same as IT. Not all techies are the same. If you know the show, there are these sort of three characters. Sheldon's a theoretical physicist. What I used to do, I was a theoretical physicist. Sheldon's he's a little goofy. He's very introverted, kind of has bad social skills, likes to work by himself, super bright. Then there's Howard. Howard is the engineer. He's the MIT engineer. He has a master's degree. He's always, he's not a PhD, but he's super bright. But he's a little creepy, and he has a totally different personality than Sheldon. Then there's Leonard, who's sort of the star of the show, the most normal guy of the show. He's applied physics. He's an experimentalist. And he's the data scientist. And what I want to point out is you're going to have people in your technical organization supporting you, doing these things, they lead, and they all have different personalities. And these personalities affect the structure of the teams that you're working on. So for example, you might have people in a data science group that there's just like a data science organization. These teams are good because they do, high-end research. I certainly kind of stuff that I do, but it's also, they can be very isolating. They can be very isolated. They're very researchy, and their work can be very difficult to productionalize. And part of the reason for this is just the nature of their personalities and how they structure their teams. It's like a little PhD team, PhD group. The other problem is that you're hiring people fresh out of school who understand data science, but they've never written any production code. So they don't know how to put things into production. Then you have software and IT services. This is sort of Howard's domain. Well, they're great at managing code and writing systems, but they're not mathematicians. They don't work with data. It's not what they do. And they don't really deal with a lot of ambiguity. Science is a very ambiguous thing. And when you're dealing with software and IT, it's much more process oriented. It's much more, here's how things are going to work, and you know how it's going to work. So it's not a great fit for doing data science. The Leonards of the world, typically what I see is in systems, in organizations that are more mature, have an embedded data scientist. This is someone who can work with the engineering groups, can work with the business groups, and can solve problems, can build solutions and deploy them. And so when you're looking at teams, these are the kind of things I want you to kind of get across, the idea that not all techie people are the same. You're going to have different cultures and different personalities, and you're going to have to manage and work with them. Now, I sort of added a little special talk here. This is something new I've seen a lot in my consulting practice, is what I call the FANG managers, guys from FANG companies who Google or Amazon or Netflix, and they leave and they become a manager in another company. And I sort of call these guys the fallen gods. You know, if you've seen the Marvel movies, these guys have basically been living in Asgard, the Golden City. Google is amazing in terms of their infrastructure and their technology and of course, their capital resources. And what they find out is when you leave Google, the earth is flat and they've fallen off the end of the world. And why is that? Well, you know, it's kind of like the analogy when Thor in the movie was sent down to earth, you know, they have no powers anymore. He doesn't have his power. Why? FANG infrastructure, a place like Google, Amazon, they're 10 to 20 years ahead of the rest of the industry, maybe more. And by the way, it was the same in Wall Street when we had guys who would tell us, you know, a managing director of Goldman Sachs, who would say Goldman Sachs is 10, 20 years ahead of everybody else in terms of what they have in infrastructure. So there are these people who come from these really, really high-end places, and they're going to show up and they find out you don't have the infrastructure support to do the kind of projects that you want to do. And this is very surprising to them. You know, and so you sort of end up, someone who is Thor ends up being Fat Thor. You know, they just kind of give up, you know, or they're like, what do you do? And the problem is that you need infrastructure. You need infrastructure and you need correct data to deliver data products. And you may find that you're unless you've seen the infrastructure being built from the ground up, what do? So the solution to this is you have to think like a beginner. You have to cultivate a beginner's mind. And in some sense, you guys have an advantage if you haven't been there, because you haven't been spoiled by all the great products and toys that they have at Google or Amazon. So what I say is you go in, you have to think like a beginner. You need to see the entire process. You're probably going to see a lot of it end to end. You have to try to understand how systems get built. So if you're going to have assumptions, you want to test your assumptions, literally. If you're given a database and somebody says to you, this is the data that's in the database, go and test it and make sure that what they claim is there is actually there and that it's useful for what you need it to do. And do this early on. You have to do this early on because we have a case with a client where, you know, we're going to move into a new international market. And I had this conversation the other day. I said, you better make sure that if this is on your roadmap for next year, go in today and make sure the data is being logged correctly and you know what it is, because you can fix the problems now before you need to get to it 6 months from now. And then you never stop looking because things break. So you have to be able to monitor your systems, your data systems all the time. They have to stay up and they have to be correct. You want to be able to distinguish between statistical versus structural outliers. So when you're looking at your data, you have to understand what are things that are just statistically improbable versus real errors, structural errors in the data, structural problems that you have to eliminate. If your data is broken, you need to find a way to repair it. Maybe you can fix the data if you're going to be doing it. If you're going to be building models, start with simple, robust methods. Sophisticated models are more sensitive to errors and are more easily overtrained. So you may have someone say, I want to make this very sophisticated machine learning AI model to do something. You say, well, before you start down that path, let's do a simple, what we call in physics, back of the envelope calculation to make sure everything is working. And try to get everything working end to end inside your entire environment before you go building these fancy models. And people, you know, it's a hard selling. Look, we want to have fancy models. We need to generate revenue. We need to get a win. But for a lot of projects, getting something wired up end to end is a huge task. Then you need to figure out how are you going to evaluate your predictions. You know, if you come to a place like, if you're at a place like an Amazon, there's probably a team there that are a team of, you know, PhD level statisticians, and they're able to run A/B tests and test for you, and they're able to tell you how your models are doing. If you go into another firm, they may not have that person. That may be totally on you to do that. So you better make sure you know how to do it or hire the right kind of staff to do it, and then recalibrate your models if they're not working correctly. You know, don't get to the point where you go out and buy half the inventory in Columbus, Ohio, and then you have to sell it because, you know, you overpriced it. Tools. the last part, I'll just kind of talk quickly about that. Tools. What are the kind of tools you need? Well, when you think about tools, I first like to point out that it's algorithms and not data lakes that generate revenue. Things like data lakes and database systems, these are cost centers. Algorithms are the things that help you. But how do you build them? Well, you're going to need infrastructure. You need data storage, cloud services. Maybe you need Hadoop, Spark, Amazon. Some maybe Amazon Redshift, Google BigQuery, things like this. You're going to need analytics capacity. You have to be able to measure what's going on. You have to know. You're going to need operations. If you're going to be building new kinds of models or data platform, data products, you're going to need to be able to keep these products running. I've seen major clients, big clients with millions of customers whose databases will go down for 3 days. Database is down for 3 days. How does this happen? So you have that, it blocks everything. So you need to have operations. And then if you want to do growth and innovation, you're going to see a lot of machine learning and AI. There are a lot of buzzwords, but it does work. And you're going to need it. That's really the key that I think you guys are going to see in the next 10 years or so of where the growth innovation is going to come from. In terms of what you need to know, not only, you need tools that, what does the team need to know? They need to know their metrics. What KPIs do you already have? And what are you trying to hit? And you need to know whether the APIs are meaningful or not. You need access. What tools can you access? What can you get? What can you actually get access to? And a lot of systems, are they self-service, or do you need to go and request it from someone? Impact. What impact is your tooling going to have? If you start building tools to support the business, you're going to impact all sorts of other people. They're going to start using your tools. If you build a database system, people are going to want to go into and use it. And the last thing I want to talk about is truth. What is reliable and what is not? And this is probably the hardest thing to really absorb in the organization. What is truth in the organization? I can tell you that I've heard that, I've seen systems where you'll have a financial reporting system. They have two systems. They'll run two different reports on the exact same data, get totally different results. So understanding what your tooling is really trying to, the impact is not just impact, but what is the truth in the organization? The last point I'll talk about is, let's see if I have it here. Algorithmic accountability. I'll just make this last comment because I thought I would go for about 40 minutes. The last point is that, look, we see a lot of things like the Epics of the Zillows of the world building algorithms, and then they're just falling down. And I've been in this space. I've seen it happen in eHow. I see other people do it. And what I try to say is, you need to really think about algorithmic accountability. And by that, I mean, look, an asset is an economic resource. So anything that's tangible or intangible that is capable of being owned or controlled to produce value, and that is held to have positive economic value, is considered an asset. These database systems and the algorithms that you're building are assets to the organization. And you're going to have to, there has to be accountability, not only into truth as to what it delivers, but the impact that it has on the business. And these can be incredibly valuable assets. And I just encourage you to think of them as, very, very valuable assets, and treat them with that kind of respect that they need. So I'll stop there and open up the questions.
Thank you so much, Charles. So does anybody have any questions? Could you please come here?
Hey, Dr. Martin, thanks for being here.
Sure.
I have a question more, I guess, meta to the machine learning world. It seems like some of the problems we've identified come down to human error, kind of garbage in, garbage out. Are there projects and works for machine learning to identify better machine learning, as in to develop better models?
Yes. I mean, I actually have a friend who's associated with an open source system where you're trying to validate when you put data into the system. Can you put validation to make sure the data is what you think it is? And I think there are people trying to develop products where you would be able, I think what's it called? It's called Great Expectations. I think that's the name of the project they're working on. to try to build a tool that would evaluate what it is. But I want to emphasize this idea again, that it's not so much error in that, look, if I build a product, that product, you know, you have to spend a certain amount of cost to build it. And, you know, it has certain constraints, quality constraints. If I build a billing system, you know, it has to bill your customers. If you don't test the system for other things, it won't behave that way. And what happens is that complex systems you might actually build a product that works correctly, and then over time it gets corrupted because people modify the product in ways that what they're doing is correct. Like you might modify the product. Like a good example is I have a customer database, and I'm doing a problem where I have to treat some collection of customers and give a report on them. But the database only has like the records are only one customer per record. One row is a customer. So I go in and I insert some record in the database that's something like dummy customer. And in the dummy customer record, I put my data. Then you leave the company. And what you did was correct, and you built a tool and it worked correctly. Somebody else comes into the organization and they see this and they don't know that there are all these dummy records in the database, because at the time it was done, it wasn't a mistake. So these are very, very complicated systems, and you have to be aware that over time systems just they evolve this way. And so it's very, and so you really have to, my best advice is to try to get in early and find out what you really have. And try to, and if you can, find tools that you can run on your data systems to validate what you think things really are.
Would those tools be something like your Weight Watcher system?
That's a tool I built. That I've built. It's funny you asked me about that. That I've built to try to predict whether, the Weight Watcher is a tool that allows you to determine whether the layers of a neural network are overtrained. Yeah, that's exactly what it's for. Like if somebody gives you, it's sort of the idea that somebody gives you a deep neural network and they just give it to you and you don't know who trained it, you know, and they don't give you the data and you have no idea whether it's trained properly or not. So the Weight Watcher tool allows you to look at the layers of the deep neural network and say, this layer was not trained properly, go back and fix it. And it allows you to monitor it in real time. That's exactly why we built the tool. That's a great example. Thanks for bringing that up.
Awesome. Yeah, thank you.
You bet. And go ahead.
Hi, Professor. Thank you so much for your time. This is a really interesting conversation. So,
My pleasure.
In hearing a little bit about how data sets are actually used in the real world, data set like interoperability. Like if I want to create a program or a product that wants to draw from multiple data sources that are built on different platforms and different software, is this a problem that's becoming easier to solve with like new cloud-based infrastructure or other, as technology has improved? Is this a problem that's getting better or worse?
Let me tell you a story. We did a project for a big firm. I won't say who it is, but they have one of the largest Hadoop stores in the world. And a few years ago, Hadoop was sort of the big thing. And what people thought was, look, we're going to get these big Hadoop stores, which is a big data store, and we're going to put all our data into the Hadoop store. And in some sense, that's a good thing because it got all the data out of all these little silos and put it into one place. So now all your data from all your different systems are collected into one place. And then we tried to build this model for them. And mind you, they have the largest Hadoop store in the world. And when we got the thing into production, they gave us one column for the data, one field. And like, well, what are we supposed to do with this? So the problem is that you have these massive, and it was just ridiculous. Like, really, guys, one field, this is all you have? And the problem was that nobody knew what was in it. Nobody knew what was in the store. And it's very difficult to join records from different, how do you join one table to another? and be sure that the records are joined correctly. So I think the technology is kind of there, but not really. There are huge problems in trying to join data from different data sources simply because the data, it can be corrupted in ways that you don't expect, or people just don't know what it is. So I think technology wise, there are tools like Presto, which, sort of like Presto is a SQL system that sits on top of all these different databases. It was written by Facebook. So you might have a company, you might have 25 different databases, you put Presto on top of it, and you could run SQL and do joins across all the databases. Technology wise, yes, it's very good. From a data perspective, there's no way to look at the different databases and know whether the joins are correct. And I spend a good half amount of my time just trying to build a system to do that. So I think it's yes and no. The potential is there, but internally there's a lot of work you have to do to build a functioning product.
Thank you.
Hi. Hi, thank you so much. I don't know if you can see me. I can see you.
Okay, I can kind of, there you are. Now I can see you.
Okay, so my question is regarding data governance, right? So I don't have a lot of experience from the engineering or tech side of data, but I've managed, just to put an example, I managed like the implementation of Salesforce in a company that had like around 5,000 employees. Oh, can you hear me?
Yeah, I'm listening. I'm listening.
That had about 5,000 employees. And then one of the biggest issues that we had, other than like data incompatibility, and we're talking about very simple data like name, last, like people, was that the data governance was very different from department to department. And it's just, it was such a big challenge first to like get them to do it, like to clean their data, to get, like exactly the same like categories, parameters, whatever. But then on top of it, even like let go of their data and not hide their data. And then I stayed like 3 more years and I just saw it crumble again in like a crazy, like
Yes.
integrated. So I was wondering, like from the management perspective, what best practices or like examples you recommend for like good data governance? Because okay.
It's very hard. I'll give you an example. I have a friend who says, I have what I call a data black market. And inside the company, there's like a data black market. And what I do is I'll trade data for open recs. Right? So they use data as currency to get, and that's what people are doing. They use data as currency in order to move up in the organization or to get resources. That's how the organizations function. It's like cigarettes at a prison. So getting people to change this, look, the move from having everyone has their own spreadsheets. The move to putting everything in Hadoop was this idea that you could break down these barriers. But the data governance issues are very, very hard because a lot of data governance focuses around compliance. I think if there is a compliance requirement, then there's a mandate and there are resources to do it. But it's very hard because without that mandate, there isn't the budget to do data compliance or even basic data cleaning. People don't have the budget. You don't get promoted for cleaning your data. You get promoted for, solving problems. I think that's a problem. Another is, it's very much this problem of, like I said, the data contraband, that people pass data around, that you have access control issues. This is another thing that you try to stabilize within the organization, is who has access to what, or how do you get access to things? And this is something which is very hard to try to get under a data governance framework, because there are some places in operations where the access control is very, very well defined, and others where it's simply impossible to get access to the data. So sometimes it's not that people don't want to give you access to the data, but that you don't have the access control governance in place in order to do it. So in other words, you're trying to access a database and nobody knows how to grant you access. And as organizations get larger and larger, you have to have a dedicated person or personnel whose job it is just to manage all the passwords and the LDAP controls and all of these things, just to manage the access control so that people can get access to the data. And then, of course, the other issue is, obviously data is not documented. So how do you put together documentation systems? Documentation is usually stale. And so you have to build systems that check the data, compliance. And there are going to be, the issues come up when, again, it's hard to do from a governance perspective unless there's a mandate for it. We had a client come to us who wanted us to build a system, a neural network for them to detect when people were misidentified when giving them credit. Because if you misidentified them for credit, it was a crime and they could be sued. And every time and there are apparently other companies that go out and will sue the firm, like $100,000 or more every time they misidentify someone. They apply for credit or they apply for, and they misidentify it, and then they get sued. And so there was a mandate to fix it. And I think that's the challenge with a lot of the governance issues, that without a compliance mandate or some other financial incentive, it's very hard to get people to do it. And getting people to use some of these, if you can get the organization to use one of these broader systems and you can control the access and you have documentation, it's easy for them. I think they will. If you build systems that are very brittle and people can't get their work done, they'll just stop doing it because they can't get their work done. And then you kind of have to break, so making, if you create barriers to getting things done, people will work around it. And so that's something you have to really work hard to make sure that the internal products are actually enabling people to get their job done. And then you have to break down this culture of this sort of data black marketing, where people are using data as a type of currency. Because once that starts to happen, then they're going to hoard data and use it in ways it creates a culture within the organization that's very difficult to break. But did that answer? I hope that answered the question. Like, it's sort of the enabling technology, focusing on having a mandate, working around compliance, having good enabling technologies, and trying to break down the culture of the data black market culture or the data hoarding culture.
I don't know if I'm on the camera now, but I hope you can hear me.
I can hear you. Yes.
Thanks for taking some questions. I was just curious, like if you've had any experience with like two-sided marketplaces, and like how do a company like Airbnb, like I assume there's a lot of data confusion because they're trying to drive both hosts and visitors to their site and like get learnings and improve the site. Like how do you make sure data is clean, and like if you're trying to understand or improve the product for hosts, like how do you know the data you're capturing from site activity is like actually from a host, not from people just visiting the site and trying to book a vacation, as an example?
Right. I think it's a common problem. I'll actually comment on it a little differently. One of the biggest problems in the industry is bot traffic. And when you start collecting data on the web, you have bot traffic. And this came up with a client who we were talking about, we're building models for a recommender, and one of the guys wanted to use carts. The carts, you cart the product. I know you can't use the carts, you got to use the purchase. Why do we have to use the purchase? Because the carts are probably bot traffic. You have to understand this. So you have to build systems that you have to understand your reliability. And I think that a lot of Silicon Valley companies are very good at this because they've built them systems from the ground up. And a lot of the problems you see with the data confusion comes in legacy companies where you have data systems that are 20 years old and they've been slowly degrading. But in any environment, you're trying to determine, is the information or is the quality of what you're doing good? Are you using? I think you're trying to ask in a two-sided marketplace, or in any time you're collecting data, you're trying to build a model around it. Is the model data you're using useful and actionable? And that's really it's not only so much a data quality issue, but it's from an issue of the modeling. And I think with Airbnb, they may have actually brought in, they may have acquired I think it was Airbnb. They had acquired a fellow who actually they acquired companies that specialize in this sort of econometric modeling, where you are really trying to understand, given this piece of data and you build a model, does this data actually impact your model? You build it, does it have an impact on it? And when you see the predictions of the model, can you go back and attribute, did this piece of data actually attribute to the model prediction? And when you put it in the real world, can you go to the real world and correlate the actions you see in the real world with the actions you see in your models, so that you can understand, look, once you have that correlation, you can go back and look at that data point you collected and say, does this data point actually contribute to the model, or is it noise, or is it just blank? And I think it's a complicated modeling problem, and it goes beyond, there's certainly the data capture process. You're trying to avoid bot traffic, you're trying to get good data. Another piece of this is how you incentivize people to enter data into your system. If you're working in any environment where, the best example of this, I think, is Google, where people think Google's a search engine and it just searches data. But it's more than that, because you have to design your web page in such a way that Google knows how to search it. So they incentivize you specifically to create web pages that can be searched. Otherwise, you won't end up in your index. And they're not as transparent about it as they used to be. And that was a lot of our work at eHow that sort of broke that. But nevertheless, Google, in some sense, is sort of two-sided in that way, in that they incentivize people to build websites in a very specific way that they can be searched effectively. And, when you go into an organization, you build search. A lot of enterprise search is terrible. And the reason for this is that there's no incentive to get data into the system in a way that it's actionable and useful. So I think having those incentive mechanisms are are really important, so that you're rewarding people for creating good data.
How often is Google changing how postings are optimized, and are they just not sharing?
I in my other version of this talk that I gave a few years ago, I talk about this. I worked at a company, client of mine years ago, eHow, Demand Media, and we figured out a way we were able to predict how much traffic we would get on Google before we created a website, just based on the title of the site. And we figured this out, and we were like $1 billion IPO, and then Google, the story I give is Google changed CEOs, and then they totally changed all their algorithms, and they made everything far less transparent. And one of the things they did, which is critical, they introduced these penguin and panda updates, but they also did something very critical, which they don't talk much about, is they removed the inbound search query. So it used to be, when you ran a website on Google back in 2009, 2008, you could see what people were searching for when they came to your search engine, your page. So you knew what the intent was. Well, they got rid of that, because they don't want people knowing what the intent is, because you can figure out, you can kind of, figure out how to, you can game their system in a sense by understanding that. And so they've become less and less transparent. And so they have sort of a trade-off. They want people to list items in their system that are so that they get high SEO, but they don't want it to be so good that you don't need to buy ads. And so they change things frequently to try to mix it up, just to kind of keep people on their toes in the event someone figures out just what they're doing, so they can get lots of SEO and not have to buy any ads. And that was a direct result of our work at eHow.
I appreciate the insight.
Sure.
Sounds good. No more questions? Thanks so much, Dr. Martin. So thanks again. It was really great. We're glad that we had you. So there is no more question, and I don't want to take your time anymore. Thanks again. Please, thank you, Dr. Martin.
Oh. Thanks, guys. I appreciate the chance to do it and the feedback, and I wish you all the best of luck.
Thank you.
All right.
Have a good night.
Thank you. Goodbye.